Hi, in the last session, we introduced telecom industry in very brief and we go through a very short telecom development history. Now, in this session, we will try to understand that why we need 5G and why 4G is not enough to cater our future requirements. And we will also talk about major 5G use cases. So, why 5G is actually needed? To answer this, let's explore some key trends in the telecommunications. First, let's consider the number of mobile subscribers. The number of mobile subscribers are increasing rapidly. In 2018, when there was a global population of 7 billion people, there was already 8 billion mobile subscriptions. And those numbers are actually growing very fast. And they continues to increase in 2024 as well. Alongside this growth in subscriptions, the amount of data which is being consumed by subscribers is also growing very fast. So this creates a strong need for a network that can handle this massive traffic in more efficient way. Additionally, the number of IoT devices or Internet of Things connections are increasing rapidly. So it's not just people who are connecting to the internet, but machines are also joining. So, in the upcoming years, the number of connected devices is expected to grow by 4 times from now. So, to address this huge expected demand, there is a group called METIS Group or METIS Group. This is Mobile and Wireless Communication Enablers for 2020 Information Society. They outlined the requirements for a new network concepts during 2013. So our new developments and new concept must align to meet those technical goals which are set by METIS. These goals were set in 2013 and they are related to the future network performances. This includes supporting 1000 times more mobile data per area. The new network should also support 10 to 100 times more connected devices. New network systems should also offer 10 to 100 times faster data rates for users. Another goal was to achieve 10 times longer battery life for the low power devices, especially for the massive machine type communication related devices. They aim to reduce the latency by 5 times, which will improve the end-to-end communication speeds. Most importantly, these improvements must be achieved with the new technology without increasing cost and energy consumptions compared to the 2013 levels. Other organizations in the world of telecommunications also have similar vision for the future. For example, here is a vision from 5GPP for the future, where not just people but entire cities or infrastructures, homes and devices are fully connected with each other and they will empower their maximum potential. And this brings us to the question that what exactly is 5G? Well, I will say that 5G is not just one technology, but it's a collection of technologies which are designed to deliver the advanced network performance, which we have just discussed, and it supports a wide range of new use cases. 5G introduced a new air interface called New Radio or NR, and this will work along with a completely new network architecture. New concepts were also developed like network slicing, massive MIMO, bandwidth part, numerology selections, and many more new things. Okay, so now let's move to the 5G use cases. But before this, we need an overview that how exactly 5G will be used and how does it differ from the 4G network. In the starting, 4G mainly supports mobile broadband, which allowed us to do things like checking emails, browsing the web, streaming videos, and listening to music, downloading contents, etc. and this kind of stuff. But 5G expands on this by introducing four major categories of use cases, each use case offering new possibilities beyond what 4G can do. The first use case is enhanced mobile broadband, which is most straightforward. As people continue to use more broadband services, 5G will enable even higher quality experience like streaming 4K and 8K videos and even 360-degree videos, watching virtual reality contents and augmented reality contents, playing or streaming video games, etc. And all these with faster speeds and more reliability. The second use case is fixed wireless access. Well, 50% of the world's population is still waiting for a reliable broadband and internet connections, and they are still depends on the fixed wired connections like fiber at home, etc. This is particularly in a suburban and rural areas. 5G can help us here. by allowing telecom companies to use their existing cellular infrastructures to deliver broadband and high speed internet services to those users, of course, with more reliability. For example, here you can see a typical scenario where the spectrum assets owned by some operator is underutilized in suburban and rural areas. They can use this unused spectrum and existing sites to provide a fixed wireless access through a device called CPE. This is Customer Premises Equipment. This device connects to the 5G network and offers Wi-Fi or Ethernet to the home devices, just like a Wi-Fi hotspot device. And this can become the main source of internet in the future. Hence, fixed wireless access also provides an additional way to generate revenue for the telecom operators on top of their mobile broadband revenues. The third use case is massive machine type communications. You may think about the sensors that are installed in your vehicles or homes or offices, and they capture the relative informations and sends to the host or communicating with each other. Or maybe they installed in vehicles and track the location of your device. Or think that these sensors are set up in your garden and monitors the environmental conditions like humidity, wetness of soils, sunlight, etc. These sensors send a small amount of infrequent data, so we can control the power consumption of such devices. And the expectation from such devices is to have a long battery life, like many years from just a couple of batteries. This category of devices are expected to be in huge numbers in future, and 5G is designed to handle a large number of those devices within a single area, which make it perfect for smart cities, agricultural areas, and other applications where many devices need to communicate with each other. The fourth use case is ultra reliable low latency communications. To understand this, take an example that there is a surgical robot in a hospital and one surgeon is controlling that robot from a remote location. Then the connection between these 2 points plays very important role. So during a surgery, the connection needs to be extremely reliable with no downtime, because even a small interruption in the connection can disrupt the whole operation. Secondly, the network also must have very low latency, so there would be no delay in the robot response. This type of communication is essential for critical applications like remote surgery or self-driving cars, etc., where reliability and speeds are very crucial, because it will be very difficult to perform a surgery when the robot has a huge lag from the controlling point. This kind of applications are called ultra reliable low latency communication, and this type of communication will also serve by 5G. In conclusion, 5G is designed to serve different use cases. These are beyond from the mobile broadband use case, so 5G is going to handle some very fascinating and challenging use cases in future. 5G is not just about faster mobile internet, but it opens up a wide range of new and exciting possibilities, from enhanced mobile broadband to support a vast number of connected devices, and even it will enable to support critical applications like remote surgeries and self-driving cars, etc. So that's it for today. In the next session, we will be talking about 5G systems and a brief about the control plane and user plane, and control plane and user plane separations or CUPs. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.